In the forests of Asia and Africa, on the underside of a leaf, something is flashing. It's not a firefly, nor a stray reflection. It is the abdomen of a spider from the genus Arachnids. Seen in macro, the surface shimmers with an impossible metallic sheen, like a tiny, perfectly polished ball bearing. But this object is alive, and it is putting on a show. The surface doesn't just shimmer, it pulses. A rhythmic, hypnotic throbbing emanates from within, patterns of light swelling and receding like a slow-motion strobe. This isn't a simple twitch. The entire structure seems to be in motion, a controlled, deliberate beat that has baffled arachnologists. What is happening inside this tiny creature? To understand the light, you first have to understand the movement. The spider is actively contracting muscles within its abdomen. Imagine flexing a muscle under your skin. Now imagine that muscle is coated in microscopic mirrors. As the muscle shape changes, the angle of every single mirror shifts in unison, creating a wave of reflected light. This isn't bioluminescence, the chemical light of a firefly or a deep-sea fish. The spider isn't producing light at all. Instead, it is masterfully manipulating the light that is already there. The phenomenon is called structural coloration, and you've seen it before, perhaps on the wing of a morpho butterfly, the neck of a hummingbird, or a soap bubble. Inside the spider's abdomen, beneath a transparent layer of cuticle, are specialized cells called guanocytes. These cells are packed with microscopic crystals of guanine, the same molecule that forms one of the 4 main bases in DNA. These crystals are stacked in incredibly precise layers. When light enters the spider, it hits these stacks of crystals. Some light reflects off the top layer, while some passes through to reflect off deeper layers. These reflected light waves interfere with each other. Depending on the exact spacing between the crystals, certain colors are canceled out and others are amplified, creating the intense metallic color we see. The true magic, however, is the pulse. The spider is physically altering the spacing between these guanine crystal layers by contracting and relaxing its muscles. This is like retuning an instrument in real time. A slight compression changes the distance the light travels, shifting the reflected color and intensity. It's a biological machine built for manipulating light waves. This leads to the central and unanswered question. Why? What is the purpose of this silent, rhythmic light show? One of the leading hypotheses is that it's a form of camouflage. The pulsating, silvery orb might perfectly mimic a glistening droplet of water or dew clinging to a leaf. To a passing bird, the spider might not even register as food. The movement could be key to this deception. A static, shiny object might still attract attention, but a shimmering, pulsating object could look more like a natural reflection on a water droplet trembling in a slight breeze. It's a high-tech form of crypsis, hiding in plain sight by pretending to be a part of the environment's physics. Another possibility is that the flash isn't meant to hide the spider, but to attract its next meal. Some nocturnal insects are drawn to light, a behavior called positive phototaxis. Could the cert arachne be a tiny anglerfish of the forest, using its pulsating lure to draw in unsuspecting moths or flies? A flash in the dark is a powerful signal. The pattern is so distinct, so rhythmic. It could also be a language. Perhaps the pulsating display is a courtship signal, a visual song to attract a mate. Different species of fireflies use unique flash patterns to find each other in the dark. It's possible that the frequency and intensity of the spider's pulse communicates its species, fitness, and location to other Certarachnae. What makes this display so extraordinary is its uniqueness among its kind. Spiders are masters of silk, venom, and camouflage, but active light manipulation is almost unheard of. Other spiders, like the mirror spider, have static plates of guanine that create a beautiful mosaic, but they don't pulsate. They are fixed mirrors. The Certarachnae is a dynamic signal. This spider has evolved a system that is, in principle, similar to technologies we have created. The layered crystals act as a thin film interference filter, or a Bragg reflector. We use these principles to create specialized mirrors, anti-reflection coatings for lenses, and even some types of fiber optic cables. The spider, through millions of years of evolution, built one into its own body. And it's not just a passive piece of technology. It's integrated with a neuromuscular system that can play the instrument of its body. The signal originates in the spider's ganglia, its version of a brain, sending electrical impulses that dictate the rhythm of the flash. It is a deliberate broadcast. When we look at this spider, we are observing a broadcast without a decoder. We see the signal, the pulsating light, but we don't know the message. Is it saying, "I am not here" to a predator? Or is it saying, "I am here" to a mate? Or perhaps food is this way to its prey. The meaning is entirely dependent on the receiver. This reflects a fundamental challenge in our own explorations. When we point radio telescopes at the sky, searching for extraterrestrial intelligence, what are we looking for? We're looking for patterns we can recognize, signals that stand out from the cosmic noise. But what if a signal is so alien we don't even perceive it as a signal? It might just look like a strange pulsar or a random burst of energy. The Certarachnae spider is a terrestrial version of this problem. It is broadcasting information using a medium dynamically controlled structural color that is profoundly alien to our own methods of communication. Its body is both the transmitter and the message, a living piece of biological optics. So the next time you see a glint of light on a leaf, it might not be just a dewdrop. It could be a conversation you don't understand, a warning you can't interpret, or a trap you don't recognize. It's a reminder that the world is filled with signals and that some of the most complex messages are being sent by the smallest of creatures, flashing silently in the dark.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.